Hi, Cutie Patootie, Math Angel. Welcome back. This is Decaf-Math ASMR. I hope that this finds you well. Today I'm going to be casually chatting and reviewing hypothesis testing, and I will timestamp where I start to do that later in the video in case you want to just skip right into the math review. But for now, I just want to take some time to ground myself and invite you to ground yourself here in our little math nook. So take some time to make yourself nice and comfy and cozy, whatever you need here. I just want to emphasize that this is our safe space to learn, study, review, be uplifted and encouraged, maybe catch a little ASMR tingle or two. But that's why I am soft speaking and whispering, by the way. I was thinking the other day how random it must be if like a person just stumbles upon my channel and just hears hi Cutie Patootie, Math Angel, and then wondering why I'm soft speaking like this and whispering. But hopefully, if you are new here, that you feel welcome with open arms, and just jump right in to our little math nook here as we review and learn and encourage each other here. So I just wanted to emphasize that and let you know that that's exactly what the intention of my channel is. And I'm realizing, that it's really hard to keep up with every single person now. So I do have a list of topics and ideas, both for the ASMR side and for the math side of this channel. So I appreciate your patience and just continued support in general as I jump around. And also, these days I kind of have to go with the flow with my uploads, so I do apologize that I'm not able to upload or film as often as I would like, but I am doing my best. And so I'm always very grateful when we get to hang out. Thank you for continued subscribers and viewers here too, who always offer support and a kind word, whether or not they're studying math. That's always very much appreciated. But yeah, I'm realizing that it is hard to know what level anyone is actually studying if they want the math help. So I want everyone to feel included and welcome. So you can always use my videos to actually review, but you can also just use them as background noise or just a little company for someone doing something or working on something else. So it's all up to you. And just remember, if you happen to find whatever material easy or something, that there's always someone who can use your unique way of explaining things. And if you happen to feel very behind, just know that you have at least a little community here to love and support you. And if nothing else, I'm praying over this channel, sending much love, and so I'm just going to get into random comfy chatting here. Okay, so on to our comfy, cozy, casual review of hypothesis testing. Hypothesis testing in statistics. Let's start by going over what a hypothesis is in the first place in this context. So in statistics, a hypothesis is basically a statement or a claim about a quote-unquote population, and we're going to be testing this claim. Okay, so I put population in quotes because we might just assume that we're talking about populations of people, but in this context, a population can be whatever set or group that you are interested in studying. So you might be talking about a particular subset of people or something like that, like maybe you're studying a particular neighborhood or country or whatever. But you can also think of population as, for instance, the set of goods that are produced from a particular factory or something like that. Just tons of examples here, but just think of population as the overall group that you are interested in studying, and our claim is going to be about some attribute or parameter of this particular population. And then when we test this claim, we are going to be gathering data from a subset, a sample of this population. Hopefully it's a representative subset or sample. And then that's where we collect the data about this particular attribute or parameter. And then that's where we do our calculations, the math, the statistics part. And then we draw our conclusions from there. Okay, so basically a claim about a population, and we're going to be testing that claim, and we test by sampling. All right, so this is just the general idea here. Now, for hypothesis testing, there is a very specific setup that we need to follow, and if we follow that and we do all the math, there are very specific conclusions that we can make, okay? And it has to be phrased a particular way. And I'm saying that because I'm trying to imply that there are certain conclusions that we cannot say or come to. Like, we cannot write out or, just that we can't conclude. So we have to be very particular in the way that we write our setup and our conclusions. And so since we're not focusing on the math today and we're just trying to do an overview, it's particularly important to follow and understand how the actual hypothesis testing works, okay? Because it can be a little confusing. So first step is we need to write out a null hypothesis, N-U-L-L, a null hypothesis and an alternative hypothesis. Sometimes it's called the research hypothesis. So for the null hypothesis, we write H sub 0 or H naught, and for the alternative hypothesis, we write H sub A. Okay, so this is the part that gets confusing sometimes, but let's think of it this way. The null hypothesis is actually not the thing we're testing. So the claim that we're making when we say that there's a claim that we're going to test actually is going to be part of the alternative hypothesis, the research hypothesis. The null hypothesis is going to be our current default claim or default assumption or value. So if you are trying to say, what is it's not a question. Okay, so we would say the average number of pets in a particular household in a particular neighborhood is, and then let's say the average is 1.5. Okay, no half pets, we're talking about average, right? So let's say that this value is our default accepted value based on past studies or research or censuses. What's the plural of census? I don't know. But a census or just the general accepted situation. Okay, so it might be a particular value for the parameter that you're studying, but it also could just be your default situation. So like if you're testing if a particular drug has an effect on a group of people, whatever population, your null hypothesis is going to be that there is no effect, right? So you just assume whatever default state. There's no reason to change anything if you don't have to. I guess is kind of how we think of the null hypothesis. So the claim that you're trying to test basically kind of falls into the alternative hypothesis part, and that's what we are actually going to test. So it's kind of like the opposite. You have opposite situations, so the null hypothesis and the alternative hypothesis are mathematically like actually opposites. Depends on the context of your study. Sometimes depending on the actual context, usually you'll have something like the average equals something, and then your alternative would be that the average does not equal something. Sometimes you have like a value that's greater than something, like a parameter that's greater than a value, and so then your opposite, or your mathematical opposite, is that it is less than or equal to something. And depending on the context, sometimes you don't have to do like the full less than or equal to. You can just say equal to, but just logically, your null hypothesis and your alternative hypothesis need to be opposites, okay? Like mathematical opposites, mutually exclusive. So what we're doing in the hypothesis test is that it's our null hypothesis that's kind of on quote-unquote trial, right? So the idea is that we're going to get a sample, collect the data, and that data will either we will decide based on the math and analysis of that data, our calculations. We are going to either reject that null hypothesis in favor of the alternative hypothesis, or we fail to reject the null hypothesis and we kind of quote unquote accept it, but we have to go back to the wording of that. Okay, so we either reject the null hypothesis in favor of the alternative one, or we don't reject it, and that's it. Okay, so how do we determine this? Well, we're not doing the math today in the actual calculations, but essentially we are taking a sample of this population, collecting the data, and we calculate the likelihood or the probability of getting a sample with that result, or just kind of like how far of a deviation, or like how likely would we get this result, like a sample with this result, or further out, right? So basically we do the calculations, we use a test statistic, so this is where the numbers come in. But if, let's say, I'm expecting the average something in a population to be a particular value, and then I grab a sample and I look for the average in that sample, and I get something that's really far off from the expected value in our null hypothesis, okay, then, well, it's possible that this was just a fluke, that I just happened to grab a sample that gave me a very different value. But it's also possible that if it deviates far enough that I would want to just reject my original null hypothesis. It seems like, oh wait, to actually get a sample with a value that far might make me kind of question my null hypothesis in the first place, and then I would just reject that in favor of my alternative one. Because remember, our null hypothesis and the alternative hypothesis are opposites, right? So that's the whole calculation. It's about the probability of getting a sample with that result that deviates that far. So if your null hypothesis is just that the average value of something is some number, and your sample just gives you something that's very close, then you don't really have reason to reject that original null hypothesis. But if you get something that deviates far, right, far away from that value, you might start to think like, well, it might be possible that I just got a sample that gives me this value that's far away, but it might be significant enough to just think that my null hypothesis is incorrect in the first place, so we'll just reject that. So this concept of we're going to calculate a test statistic, and that will give us the idea of this probability. This is what we're talking about, p-values, and we want to set up what is exactly statistically significant enough for us to reject our h0. So there are particular values that are typical to use, and we, of course, because we are sampling, whether we reject the null hypothesis or fail to reject it. We can never be 100% sure, right? Because we are sampling a subset of the population. There's no way to actually ask the full population, right, to get a concrete answer. So that's the idea of, our confidence levels, and that's related to the level of significance, right? So that's where we decide where are these cutoffs that we will set to say that this one deviates too far to where we are going to reject our null hypothesis, or this is within an acceptable deviation, right, from our expected value. So I hope that makes sense. If you are reviewing this, I hope that you're following along. If you are hearing about this for the first time, please, by no means should you let me scare you away from this. I'm just trying to highlight common areas where people get confused. So of course, if this is the first time, take your time with this, or maybe you can look for a proper explanation, but I'm just trying to build some intuition here together. So just to emphasize again, the results that we will get from a hypothesis test is either that we reject the null hypothesis in favor of the alternative hypothesis, which is why it's important to phrase them in a way that they are mathematically actually opposite, or we fail to reject the null hypothesis, and so we just leave that be. Now, in both cases, we are not proving anything, okay? So we are assuming by default that the null hypothesis just remains true. It's kind of like in a typical example when you first learn about this is that it's our judicial system, right? So you are innocent until you're proven guilty. So essentially we are just going to put the null hypothesis on trial. We're going to assume that there's no need to change our past research or studies or assumed value. And if we reject it, we're not saying that we proved the alternative hypothesis is true. We're just saying that we are going to reject the null one in favor of this alternative hypothesis, okay? But there's no proving anything. And then, and also with the level of confidence, like we said, typical numbers and statistics are 95% or 99% if you've done confidence intervals before. But you might say, I am 95% confident that I will reject this null hypothesis. So you reject it in favor of the alternative hypothesis, but you're not proving that. If your data gives you some p-value that makes you fail to reject the null hypothesis, you are also not proving that the null hypothesis is true. You just failed to show that it is guilty, but that doesn't mean that it's actually innocent, right? You can't actually prove that fully. So the actual conclusions are going to be not proofs, but just whether or not you're going to reject or fail to reject your null hypothesis, okay? So the way we set it up is actually kind of the opposite. The claim that you're making about the parameter kind of belongs in this alternative hypothesis section, and your null hypothesis is that nothing changes or your current value is fine, okay? From there, because this isn't an 100% situation, we can make errors. So there are type 1, type 2 errors, basically that have to do with like if you should have rejected something, but it wasn't actually supposed to be, that kind of thing. It's just a concept to kind of keep thinking about. And that's it. So we basically just need our null and alternative hypotheses, and then we get a sample and we calculate our test statistic, our p-value for the probability of getting a result, a sample that gives us that result or something that deviates further. And if that value, if that probability, we have to pick a level of significance that we are going to, it's like our cutoff, right? Like how far away, like how far, doesn't need to deviate in order for us to just decide, hey, that's too much for it to be truly like a fluke in our sample, and it's genuinely so far that I think I'm just going to reject my original null hypothesis. And then that's it. So you decide if you are going to reject it or you fail to reject it. And then that's it. So you need to have these pre-established levels of significance, and you can also then find your level of confidence that you did the right move. And then of course there's always a little bit of a chance that you made an error, so we have our type 1 and type 2 errors, and that's about it. So if you keep in mind this idea of the judicial system, your null hypothesis is just no reason to change our research, our current values, our current assumptions. The drug, has no effect on a certain population, and then your actual research is going to be part of the alternative hypothesis, the research hypothesis. I think you should be good to go. From there, it's just doing a bunch of calculations, and then, keep in mind if you get a certain value, just make it make sense in this context. Anyways, that's been enough yapping. I hope that this is some nice intuition building for you. Again, if you are learning this for the first time, never ever let me scare you away from the math. I just hope that this is actually interesting. If you take it step by step, it is actually quite fun if you don't get lost in all the math here. But if you are asleep right now, I'm wishing you sweet, sweet mathy dreams. If you're continuing on with the rest of your day, I hope that it's a good one. Thanks so much for tuning in here.